In this video, we're going to talk about how to take derivatives of exponential functions, and it's super simple. So we're going to go through just a few examples. Here's your form, okay? So we're asked to take the derivative of e, so it has to have base e, to some power that has a variable in it. Basically, that's what f of x is. E to a number is just a number, so if you took the derivative of that, it would be 0. But so if you have a variable in your power and you're taking the derivative, here's your formula. Notice that everything stays the same. This e to the f of x is exactly the same here. So I'm taking exactly the function that you're given times the derivative of just the power. That's what this is. So f of x, I would be multiplying by f prime of x, the derivative of the power. Now again, and you'll notice in other videos if you watch them, some people remember it like this and they see the notation in their head. But if you're trying to memorize it, a lot of times it's easier just to think of it in terms of words. Say this a few times and you'll have it memorized. For exponential functions, everything stays the same. So exactly the function you see times the derivative of the power. That's pretty easy. Let's look at this example. So the derivative of y would be dy dx. Now, everything stays the same. So I'm going to take that whole function there exactly like you see it. 3 times e to the 5x squared. And then I'm going to multiply it by the derivative of just the power. So you do have to know the power rule for that. The derivative of that would be 10x. The 2 gets multiplied by the 5, and then we subtract a power. Now this is fine. This is my derivative. I can clean it up a little bit and I can multiply this 10x by this 3 and put it in front, which is the way I like to write it. So 30x, and then I have e to the 5x squared. So this is your derivative. Again, you can leave it like this if you wanted to, but most of the time you'll see it simplified. Okay, let's look at this example over here. Again, the derivative is going to be, everything stays the same exactly the way you see it. Negative 2e to the 3x squared minus 4x times the derivative of the power. Now this is the power, and it has more than one term. So since it has more than one term, when I take the derivative, I'm going to put it in parentheses. So the derivative of 3x squared is going to be 6x, and the derivative of negative 4x is going to be negative 4. But because there's two terms there, I really need to be careful and I need to put it in parentheses. So if I do decide to simplify this, I can multiply this negative 2 by this, but I would have to distribute it all the way through. And that would be negative 12x plus 8, and I would put that in parentheses, okay? Because that's, we distribute it. I can't separate these two. And then I have the e to the 3x squared minus 4x. Now, you could actually distribute this whole e to the 3x squared minus 4x to both of those, but you rarely see it like that. So I would probably leave it like this. Okay, last one. Derivative of 6e to the 2 sine x. Now, in order to do this, you do have to know your trig rules, the derivatives for those. So if you need to go back and review, do that. Again, everything stays the same times the derivative of the power, and the power is the 2 sine x. So we take the derivative of that, we get 2, and the derivative of sine x is cosine x. So really this is it. Again, if I was going to simplify this, I would take this 6 and this 2 and I would multiply. And you will generally see me write my trig function here in front, and then I would write maybe e to the, and I probably put times there, e to the 2 sine x. There's no like pretty way to write this. You could switch these. You could put 12e to the power of 2 sine x and then times cosine x. So it doesn't matter what order as long as you're careful. And I just put the dot right there so people don't think that it's in here. The other way is you could put this x in parentheses. You could do that as well. So just be careful when writing it. You could actually leave it like this if you wanted to. Okay, that is how you take the derivative of exponential functions. So review any videos that you need to on trig rules or chain rule, and I will see you in the next video.